Hi guys, so I'm gonna guide through 3.8 section with you guys. It's about exponential functions, the growth and decay functions. Okay, so the first problem that we're gonna go through, the first problem we're gonna do it together, and the second problem is on your own. But after first problem, you should feel confident about the second problem. But if you have questions, any questions, just ask me. Find me in the class, after class, before class, anytime. Text me or email me about the questions, okay? Okay, so we're gonna read the question first, okay? So if you guys can pull it out from your handouts from the website, then you guys can read this question with me. So a 200 Fahrenheit cup of tea is left in a 65 Fahrenheit room. If the temperature of a cup of tea is 180 degrees in Fahrenheit after 20 minutes, then what is the temperature after 40 minutes? And when will the cup of tea have cooled down to 90 degrees in Fahrenheit? And it says approximate in hours. So the first part of the question was, if the cup of tea cooled down to 180 degrees after 20 minutes, then what's the temperature after 40 minutes? So we have to use the Newton's cooling law for this question. To solve this problem, use the Newton's cooling law, which is d of t over dt is k times t of t minus t of surrounding environment. Okay, so we're going to substitute the temperature of a room gives, which is temperature was 65 degrees in the room. So you're going to substitute that as T of T minus 65 degrees. So using the equation we determine from Newton's cooling law, which is this, right? And then we're going to let y equals to T of T minus T of surrounding temperature, which is we're going to replace with 65. Okay, so we know that y of t, so if you plug in y of t here, you can do that, y of t and t of t minus 65. You can find the initial temperature value if you plug in 0, which is the time 0, and time of 0 minus 65. That's going to equal to 200 Fahrenheit, which is in the given in the question. 200 Fahrenheit, we're starting with that, minus the room temperature was 65 degrees. So that's going to equal 235 degrees for your y of 0, which is initial temperature. And we know that y is a solution to the initial value problem, which is dy by dt is ky. And we remember, like a minute ago, y equals to T of T minus T of surrounding temperature. So that was in Newton's cooling law. And then we found the initial value by plugging when the y is 0, when the time is 0 here. That's how we got 135 degrees as the initial. And the solution to the dy by dt equation is going to be the exponential function. That is the only solution. So it's going to be initial temperature or initial amount that you're going to start with times e to the kt. Okay, so using this information, we are going to plug in our initial value, which is y of t is 135, which is what we got, y of 0 when the time is 0, is times e to the kt. Okay, so now we are gonna we have some information to solve our part A question. So after the temperature of cup of tea after 20 minutes, it dropped to 180 degrees. Then what's temperature of cup of tea after 40 minutes? So in order to find that, we have the time, we have the temperature after 20 minutes, but we don't have this information. So we have time here, we have this number, time is a number, the initial amount is a number, y of t is going to be 180 degrees, you're going to replace that, it's going to be a number. The only missing information here is going to be the k value, which is our rate of decay. We are using decay rate, we are saying that it's decay because it's Newton's cooling law, that is cooling down, the temperature is cooling down, so it's going to go down, so it's decaying. And sometimes you can apply Newton's cooling law to Newton's warming law because some objects can warm it up if you apply heats to it. So, but in this case, we're using Newton's cooling law that the K rate is going to be negative, which is the rate of decay. Okay, so we're going to plug in our given information to our exponential function, which is going to be y of t is going to be, but do you guys remember the y of t? The y, we let y equal to t of t minus t of surrounding. So we're going to use Newton's cooling law here, which is tt, that part of the k times the y, which was this part. We're going to use that here. So it's going to be t of t, which is the 180 degrees, right? So I'm going to put t of t, the temperature of a cup of tea after t minutes, t time, minus surrounding temperature is going to equal to 135, our exponential function, which is 135 times e to the k 20 here. T, but we're going to replace the t by 20s here. We're going to replace by 20 because that's our given information. And let's put our other given information, which was t of 20, which is temperature of a cup of tea after 20 minutes. It was 180 degrees. Minus surrounding temperature, the t of s was 65. Equals to 135 times e to the k 20, which was 20 minutes. That's why we have time t replaced by 20. So 180 minus 65 was 115 equals to 135 times e to the 20k. I'm going to bring the 20 to the front before the k. And then what you're going to do, you're going to divide both sides by 135 and 135. And what you're going to get is, you're going to cancel out the 135 on the right side. And you're going to leave with e to the 20k. And on the left side, you're going to have 115 over 135. It should be decimal points, but we're going to just put it as exact value, which was 135. It was 115 over 135. The next step that you have to do is you're going to take natural log on both sides. Okay? So you're going to cancel out the e value here by raising to the ln. So what you should get is natural log of 115 over 135 equals to 20k. And what we're looking for is a k value, which is going to be negative. Remember that it's negative. It should be negative because it is a decay of rates, or rate of decay. So what you're going to do, you're going to divide by 20 on both sides, so you can get the k value. So the k is going to equal to all this. I'm leaving it as the exact value, but if you plug into your calculator, it's going to give you the decimal points with a negative value. ln the natural log of 115 over 135 all over 20 is going to be your k value. So we have a part that we can solve for our first part of the question. So the k value is this, the natural log of that. So I'm going to erase all this first. Oh, we needed that. So I'm going to write our needed information. Y of t is t of t minus t of surrounding, and our exponential function, which is y of initial times e to the kt, and our k value here is natural log of 115 over 135 all over 20. That's good? Okay. So now we know the rate of k by plugging our given information. Now we are looking for the part A is asking what's the temperature of a cup of tea after 40 minutes. By plugging that, we are plugging back all this given information to our equation that we were solving. So y of t equal to y of initial e to the kt, and yt is going to be replaced by this, t of t minus t of surrounding equals to 135 initial amount e to the kt. We have this one, which is t of 40, temperature of 40, but we don't have the actual temperature. We're going to just put it as that. The temperature of surrounding was 65, so T of 40 minus 65 degrees equals to 135 E. K, we have the E is the number, but K we have the value, which is natural log of 115 over 135 all over 20, and T we have it, which is 40 minutes. So what you're gonna do is you're gonna so on the right side is 135 times e to the k 40, and all this numbers, they're all numbers because we have the number here, the k value, so that's going to be negative number, so we'll have all numbers here, so you're going to simplify that.